let us solve this triple integration. Okay, so some region is also given here, but first of all I will write the given triple integral and then we will think about that region. Okay, so see, we have whatever the integration we have, we will call it as I is equal to triple integration y dv. Okay, so as well as the given region is bounded by, so we have, I will simply mention, we have what we have first. Okay, so first of all I will write y is equal to 1 minus x square. So this is a parabolic cylinder. So this is a parabolic cylinder, right? Cylinder. See, what will I do? I will draw a diagram simultaneously, as well as I will draw a diagram in 3D and 2D both, so we can easily understand. So in 3D I will draw here. So this is z axis, x axis. So this is x axis, this is y axis, and this one is z axis. And simultaneously I will draw a diagram in xy plane also. So this is x axis and this is y axis. So see, this is parabolic cylinder, but see in 2D, okay, in 2 dimension, you know that this is equation of parabola, since equation of y is 1, equation of x is 2. So I will simplify, okay, I will do many things in a rough, okay. So and after that we will draw the diagram. So see, we have x square is equal to, we can write x square is equal to 1 minus y. So that means x square is equal to, we can take minus sign common, y minus 1, right? So this is a parabola. This is a parabola symmetric about y-axis, since y has a power 1. Symmetric about negative y-axis, that means in the direction of negative y-axis, since y has a minus sign. And one more thing, its vertex at 0 comma 1, since x minus nothing is there, so that's why 0 is there, and y minus 1 we have, so it is 1. So where is 0 comma 1? 0 comma 1 is here, so 0 comma 1. So this is a parabola in the direction of negative y-axis, so we will have like this. Okay, so we have a parabola. So I will try to draw the same parabola here in the direction of, this is negative y-axis, you are getting, in the direction of negative y-axis. So it will be like this. This is negative x-axis, positive x-axis. So we have a parabola like this. Getting my point? Okay, so this is a parabolic cylinder, that means it is a cylinder, so it will be like this in 3D. Okay, in 3D we will have a diagram like this, and it will be like this. Okay, just a minute, I will try to draw it more perfect. So this is the cylinder. Getting? So I will show you. I will show you. As you can see, this is a notebook. If I fold it, okay, so see, you can see this is a parabola. You are getting, in 2D you can see this is a parabola, but see if it has some height, so this is a parabolic cylinder. You are getting the point? So this is an example of parabolic cylinder. Okay, so we have a cylinder here, we have a cylinder and its parabola, it's like this. Okay, so this was a rough part, so I will remove it. Okay, next, what is the second curve? Z is equal to 0. Z is equal to 0. This is a xy plane. Z is equal to 0. This is equation of what? Xy plane. So xy plane, that means Z is equal to 0. Xy plane means this one. Next is yz is equal to y. Z is equal to y, a plane. Okay, actually it is a plane. It's a plane. That means this is z axis, this is y axis. So you can see this line. So in that direction, okay, we will have a plane which is parallel to x axis. So this is a plane like this. Okay, I cannot draw the plane, otherwise the diagram will be more complicated. But as you can see, this is the plane. That means suppose this is y axis, this is z axis, and this is x axis. So if you consider the plane like this, so that plane we will have here. Okay, see, after that what will I do? Z is equal to plane. But see, if I put z is equal to 0 here, that means what I'm trying to do, I'm trying to find the curve of intersection. Z is equal to 0, this is z is equal to y. So where they cut each other, if I put z is equal to 0 here, we will have y is equal to 0. Get it? So y is equal to 0. See, that means in 2D, y is equal to 0. This is equation of x-axis. Y is equal to 0. So that means the region is bounded by, in xy plane, y is equal to 0, this parabola, and in 3D it will be like this. So now we have to focus on limits, right? So let us find limits now. here, okay, I will write here z. Okay, first of all I will try to find limits of z, after that y, and after that we'll go for limits of x. So limits of z will be like this. So as you can see in the here, they are given, it is, so z varies from 0 to y, you can see here. Or if you consider a strip like this, you can consider a strip like this. So yeah, a strip will be like this. So z varies from 0 to y. Next, y, okay, limits of y. So as I told you earlier, when we want the limits of x and y, so after finding limits of z, we take its projection in xy plane and we will try to find limits in xy plane. So let us do that. So the region, okay, bounded by this parabola, y is equal to, what is this equation, 1 minus x square, right? Y is equal to 1 minus x square, and y is equal to 0. Obviously, if I put y is equal to 0, we will have 1 comma 0 here. That means I told you the points of intersection. Okay, you can try in your rough getting. So see, what I to put, y is equal to 0 here, so we'll have x is equal to plus minus 1, so that's why I wrote directly. So that means this is region of integration. We are getting, so when we have a region of integration, as you know, we normally consider a strip parallel to y-axis. You know our funda, bounded below, bounded above, left to right. Bounded below, it is bounded below by y is equal to 0, and it is bounded above by y is equal to 1 minus x square. After that, we move straight from left to right. So in the left, okay, in left, you can go up to x is equal to minus 1, and in right, you can go up to x is equal to 1. So these are limits of x, y, z, right? So what will we do? Make a screenshot of it, and after that we will solve the integration. Please make a screenshot of it. Let us solve the integration now. So I is equal to triple integration, okay, y dv I will replace by dz dy dx, right? Because our consider the limits in that way. And z, limits of z 0 to y, limits of y 0 to 1 minus x square, and limits of x minus 1 to 1. So let us solve the integration. I will remove this part since it is not required now. Getting? So as you know, first we integrate with respect to z. Just a minute, I will write it properly. Integration minus 1 to 1, integration 0 to 1 minus x square. So when you integrate with respect to z, we have to consider y as a constant. So it will come outside the integration. So y will come outside. What is the integration of dz? Integration of dz is z only. So this is z 0 to y dy dx. Okay, so as you know, after that we put upper limit, we put lower limit. Okay, so let us do that. So integration minus 1 to 1, integration 0 to 1 minus x square, y minus 0, simply y dy dx. So now the integration is very simple. Y into y, we will have y square. So this is equal to integration minus 1 to 1, 0 to 1 minus x square, y square dy dx. Okay, just a minute. So integration minus 1 to 1. So let us integrate now. What is integration of y square? Integration of y square is y cube by 3. So let us write here, its integration is y cube by 3 with limits 0 to 1 minus x square dx. See, 1 by 3 is a constant. You can take it outside. So 1 by 3 is a constant. You can take it outside. Minus 1 to 1. So I am putting upper limit. So 1 minus x square raised to 3. I will not put lower limit since it is a 0 and 0 cube is 0. So I will skip that thing and dx. Okay. So now we have to integrate, but in a bracket there is square, okay, inside a bracket. So you cannot take direct integration. Either you have to substitute or you have to expand the bracket. So using substitution also we can solve the problem, but here I will expand the bracket. Do you know the expansion a minus b bracket cube? A minus b bracket cube, it is a cube minus 3a square b plus 3ab square minus b cube. So this bracket square formula we have to use to expand the bracket. Okay, please use the formula and tell me what I'm supposed to write. 1 by 3. Yes. So a is 1 and b is x square. So 1 cube is 1 minus 3. A is 1. No need to worry. B is x square. Right. So sorry, I need to write the integration minus 1 to 1. Correct. And 3. 3. A is 1. B is x square, or b is x square, x square square x raised to 4 minus x, b is x square, x square cube is x raised to 6 dx. Okay, so now simply we have to integrate. Okay, but see, x square is even function since power is even. x raised to 4 is again even function, power is even, x raised to 6 is again even function. So all these are even functions. So see, as I told you, when you have limits minus a to a, f, and function is even, what we do, 0 to a we write and f. So same technique I am going to use, okay, since function is even. So let us do that, so problem will be more simple. See, so because the function is even, I can write this is 2 by 3 integration 0 to 1, right, 1 minus 3x square plus 3 x raised to 4 minus x raised to 6 dx. So this is equal to 2 by 3. Simply tell me the integration. Okay, we are going to finish this one. So integration of 1 is x, correct? Integration of x square is x cube by 3. But here 3 will get cancelled. That means we will have simply x cube plus integration of x raised to 4 is x raised to 5 by 5. So that means 3 x raised to 5 by 5 minus integration of x raised to 6 is x raised to 7 by 7, 0 to 1. So after that we have to put upper limit, lower limit, and we have to solve the problem, but make a screenshot of it and I will finish the problem. Please make a screenshot of it. Okay, so let us finish this problem. So 2 by 3, I am putting upper limit. So if I put upper limit 1, 1 minus 1, since any power of 1 is 1, so that's why 1 plus 3 by 5 only, since 1 raised to 5 is 1, minus 1 by 7. No need to worry about the lower limit since it is 0, and 0 raised to anything we will have 0. So 1 minus 1 will get cancelled, 2 by 3. We will cross multiply, 21 minus 5, it is 16 by 35. So see, if you multiply 32 upon 105, so this is the required answer. Okay, so this is the required value of given triple integration. So make a screenshot of it and after that we will stop. Thank you. Bye bye.